Let's begin with the video with the executive summary. At Mitsubishi Chemical Sdn Bhd, inspections were carried out on the local exhaust ventilation and general ventilation system, focusing on the fume hood in the polypropylene laboratory. A qualified hygiene technician conducted visual inspections and functional tests, including smoke tasting, phase velocity, and airflow measurements, using instruments such as vane anemometers, pitot tubes, and manometers. The results showed the fume hood is operating effectively, with phase velocity reading of 83 and 89 fpm, which are within the recommended 80 to 100 fpm range. Airflow rates range from 703 to over 1,600 cfm, indicating efficient contaminant removal. The system components were in good condition, with no major damage or leaks, though minor clutter was observed near the sash. Regular maintenance, user training, and compliance with safety regulation are recommended to maintain system performance.
Firstly, I will start with introduction. This monitoring was conducted at Mitsubishi Chemical Sdn Bhd, located in Kemaman, Terengganu. This monitoring was conducted by Isha binti Irman, me, Norhanah binti Tajuddin, Wan Fatimah Amna binti Wan Muhammad Hanafi, and Umairah Quratunisa binti Muhammad Sabri. The objective of this monitoring was to perform an engineering control equipment examination and performance assessment. The process was conducted in the laboratory. Chemicals were taken from the chemical store for experiments and was brought to the laboratory and used on the fume hood. One local exhaust ventilation system was inspected. Table below shows the detail of the system.
Now, we are moving on to the methodology. The performance of the local exhaust ventilation and general ventilation system are evaluated based on the data gathered from the on-site measurement within the exhaust ventilation system. This table indicates the instrument used to evaluate the general ventilation system and local exhaust ventilation system. Firstly, we have smoke tube to indicate direction of airflow, rotating vane anemometer to measure air velocity, digital manometer to measure static pressure, tachometer to measure fan speed, bolometer flow hood to measure air velocity, and lastly, humidity meter and infrared thermometer to measure temperature and humidity. Next, for the system inspection of the hood area, we must check the physical condition of the hood and surrounding area. Next, identify the type of hood installed and its suitability for the process. Observe the condition of the work area around the hood. Conduct a smoke test at 1 duct diameter from hood face. Observe the airflow pattern and the release smoke. And lastly, hood velocity measurements were taken to measure the capture velocity using a rotating vane anemometer. For the ducting testing and measurements, firstly, we must observe the physical condition of the duct, unnecessary losses along the ducting system, and the location of dampers or blast gates. And then, identify the location for velocity pressure or velocity testing. Traverse measurement at the identified points were conducted using a pitot tube and digital manometer. And lastly, the velocity pressure and air velocity in the ducting system were then determined. Continue with the fan and motor testing. Firstly, we must measure fan and motor speed (RPM) with tachometer, and then determine inlet and outlet static pressure as well as inlet velocity pressure to calculate fan static pressure and exhaust flow rate. Next, for the standard and guidelines for LEV, we follow the phase velocity for hood, vertical sash, airfoil hood, which are Q equal to 80 minus 100 cfm per feet square for full open area, depending on the quality of supply air distribution and the uniformity of phase velocity. Lastly, for the ducting system, as indicated in the table, we refer to the range of airflow in the ducting system as recommended by the American Conference of Governmental and Industrial Hygienists (ACGIH). These guidelines are established to ensure that the airflow within the system is sufficient to maintain safe working conditions and effective contaminant removal.
From the result, we found that the fume hood system is working effectively and meets the recommended standards. The phase velocity, which measures how fast air is pulled into the hood, was within the safe range, 83 feet per minute for the current test and 89 for the baseline. This shows that the hood can capture chemical vapors properly. The airflow or phase flow rate was also good, over 700 CFM, meaning contaminated air is being removed efficiently. The transport velocity through the ducts from hood to the fan also met the requirement, between 1000 and 2000 CFM. That's important because it prevents dangerous vapors from staying in the duct. The fan performance was strong. Pressure, RPM and horsepower were very close to the baseline, showing that the fan is still efficient and running smoothly. During our visual inspection, we saw that the system is well maintained. The hood is a vertical sash airfoil type, the PVC ducting had no leaks, and the centrifugal fan was in good condition. We also ran a smoke test and it showed smooth airflow with no cross draft. That means the contaminated air goes exactly where it should. But we did notice a few lab items like chemical bottles placed inside the sash. Even though they didn't block the airflow, it's still better to keep that area clear for maximum performance. From what we observed, lab users are generally following safe practices, but there's always room for improvement. Here are some important reminders. First, keep the sash at the recommended height. Second, don't lean into the hood. And third, avoid placing too many tools or bottles inside. Even small things like this can affect airflow and user safety. Regular training and good housekeeping habits can help keep the system running well and make sure everyone stays safe from chemical exposure. So, in conclusion, the fume hood system is working well, but important to always use it properly and take care of the workplace.
For recommendation, we recommend to do system improvement. First, inspect components such as check for damage for hood ducting and fan performance, filter saturation, and duct blockage. Second, do routine maintenance for fan motor, and consider a balance between equipment and environmental factors. Third, do system testing. Measure airflow, check static pressure, and assess noise for fan issues. Next recommendation is to do work practice improvement. First, employee training. Educate workers on risk and proper LEV use. Second, monitoring and reporting. Regular air quality checks and ensure quick response if exposure limits are exceeded. Third, SOP. Provide clear guide for safe fume hood operation and maintenance. Third recommendation is regulation compliance. First, use Regulations 2000, Regulation 70, monthly inspection, annual testing by hygiene technician. Regulation 19, keep records for DOSH inspection. Second is CHRA, update system based on latest risk assessment. Other recommendation is signage, post-usage instructions, phase velocity, and emergency context.
The purpose of this inspection was to assess the performance of the local exhaust ventilation LEV system based on the USH Regulations 2000. The results show the LEV system, including the fume hood, meet the required standards. The measurements of the phase velocity and the transport velocity are within record limits set by American Conference of Governmental and Industrial Hygienists, ACGIH. The measurements shows the effectiveness of capture and removal of contaminants. The fan and ducting system were also found to be in good condition. In conclusion, the objective of this inspection were achieved. The LEV system is working well and complies with regulations. Regular monitoring and maintenance are recommended to keep its performance and ensure workplace safety.